The World Health Organization has released a draft precautionary framework addressing concerns about electromagnetic field, or EMF, exposure. Pages 20 through 26 of the draft contain recommendations particularly relevant to the electrical industry. The recommendations include the practice of two-wire three-way switching. This practice creates high magnetic fields due to the split return current. Current designs for slab floor electric heater element layouts often produce high magnetic fields. Modifying the layout to equalize current paths could significantly reduce these fields. The National Electrical Code, or NEC, and similar codes should include appendices on EMF and prudent avoidance to increase awareness within the industry. Code revision should consider low-cost design modifications that reduce EMF exposure. The NEC should include an appendix on EMF similar to the one planned for S3000, the Australian code. EMF reduction measures should be recognized as a valid justification for code changes. Two-wire three-way switching is a practice that can create high magnetic fields. In this configuration, the return current on the switch leg is split off from its return path. This can lead to an imbalance in the magnetic fields generated by the conductors, resulting in a higher net magnetic field. Slab floor electric heater element layouts can also be a source of high magnetic fields. Many current layout patterns for in-slab heating create very high magnetic fields. If the layout pattern was changed so both the current carrying and neutral paths were equal, the high field would be virtually eliminated. Wiring rules books like the NEC should include an appendix on EMF and prudent avoidance information to make those in the electrical industry more aware. Such an appendix is to be part of the forthcoming edition of S3000, the Australian version of the NEC. Low-cost design modifications to reduce EMF should be taken as a legitimate reason to introduce new codes or modifications to existing codes. Current codes are concerned only with fire and shock hazards. EMF reduction measures should be recognized as a valid justification for code changes. Equalizing current paths in slab floor electric heaters can significantly reduce magnetic fields. By ensuring that the current carrying and neutral conductors are in close proximity and have equal current flow, the magnetic fields generated by each conductor will cancel each other out, resulting in a much lower net magnetic field. The NEC should include an appendix on EMF to increase awareness within the industry. This appendix should provide information on the sources of EMF in electrical systems, the potential health effects of EMF exposure, and practical measures that can be taken to reduce EMF levels. Prudent avoidance is a strategy for reducing EMF exposure by taking simple and cost-effective measures, even when the evidence of harm is not conclusive. This can include things like increasing the distance from EMF sources, using shielding materials, and optimizing wiring layouts. Existing electrical codes primarily focus on fire and shock hazards. While these are important safety concerns, they do not address the potential health effects of EMF exposure. By incorporating EMF reduction measures into the code, we can create safer and healthier environments for people to live and work in. Modifying the layout of electric heating elements and concrete slabs to ensure equal current paths for active and neutral conductors can significantly reduce EMF. This involves arranging the conductors so that the magnetic fields they generate cancel each other out. Implementing such changes during installation can minimize ongoing EMF exposure. An appendix in the NEC could provide guidance on how to assess and mitigate EMF in electrical installations. This resource would help electricians and engineers implement best practices for reducing EMF in residential, commercial, and industrial settings. Recognizing EMF reduction as a legitimate reason for code changes would allow for the adoption of new technologies and practices that minimize EMF exposure. This could include requirements for shielded cables, optimized wiring layouts, and other EMF mitigation strategies. Two-wire three-way switching can create high magnetic fields because the return current in the switch leg is split off from its return path. This imbalance in current flow leads to a net magnetic field around the conductors. In slab floor electric heater element layouts can generate high magnetic fields if the current carrying and neutral paths are not balanced. An equal current flow in these paths creates a net magnetic field that can extend into the surrounding environment. Wiring rules books, such as the NEC, should include an appendix on EMF and prudent avoidance information. This appendix should provide guidance on how to identify and mitigate EMF sources in electrical installations. Low-cost design modifications to reduce EMF should be considered as a legitimate reason to introduce new codes or modify existing ones. These modifications can help to minimize EMF exposure without significantly increasing the cost of electrical installations. The NEC appendix on EMF should provide practical guidance on how to reduce EMF levels in electrical installations. This guidance should be based on the latest scientific evidence and best practices for EMF mitigation. EMF reduction measures should be recognized as a valid justification for code changes to encourage the adoption of new technologies and practices that minimize EMF exposure. These measures can help to create safer and healthier environments for people to live and work in. Two-wire three-way switching configurations often result in a higher EMF because the current returning to the source does not follow the same path as the outgoing current for at least one of the switch positions. This creates an imbalance in the magnetic fields, increasing the overall EMF. Slab floor electric heaters can produce substantial EMF if the heating elements are not carefully arranged. Traditional layouts often create loops with significant current imbalance, leading to elevated magnetic field levels. Modifying these layouts to ensure that the current and return paths are close together and carry equal current can dramatically reduce the EMF. Adding an EMF appendix to wiring regulations like the NEC would increase awareness and provide practical guidance for electricians and designers. This appendix could cover topics like identifying EMF sources, measuring EMF levels, and implementing mitigation techniques. Recognizing low-cost EMF reduction as a valid reason for code updates can drive innovation and encourage the adoption of EMF-friendly designs. This could include simple changes to wiring practices, the use of shielded cables, or the implementation of active cancellation systems. The draft Precautionary Framework from the World Health Organization highlights the growing concern about potential health effects from EMF exposure. By addressing these concerns through changes in electrical codes and practices, we can create healthier and safer environments. Two-wire three-way switching poses an EMF concern due to the current imbalance created in the switch loop. The current travels a different path for the return, causing an increased magnetic field. In slab electric heating systems, the layout of the heating elements significantly affects EMF levels. Designs that don't balance the current flow between the supply and return conductors create higher magnetic fields. An appendix in the NEC dedicated to EMF would provide valuable information to electrical professionals. This resource would raise awareness and offer practical solutions for reducing EMF in electrical installations. Including low-cost EMF reduction measures as a legitimate reason for code changes encourages innovation and the adoption of best practices. This allows for a proactive approach to minimizing EMF exposure in buildings and infrastructure. The WHO's draft Precautionary Framework serves as a catalyst for addressing EMF concerns in the electrical industry. It calls for a closer look at current practices and the implementation of strategies to reduce EMF exposure. Two-wire three-way switching is problematic because it violates the principle of minimizing loop area, leading to increased magnetic field generation. The greater the area between the outgoing and return conductors, the higher the EMF. In slab electric heating layouts, EMF can be minimized by using a grid pattern where adjacent conductors carry current in opposite directions. This effectively cancels out the magnetic fields, reducing overall EMF. An NEC appendix on EMF should include information on various EMF mitigation techniques, such as using shielded cables, twisted pair wiring, and optimizing grounding systems. It should also address how to measure EMF levels and interpret the results. Promoting low-cost EMF reduction measures as a justification for code changes encourages manufacturers to develop EMF-friendly products and systems. This can lead to wider adoption of these technologies and a reduction in overall EMF exposure. The draft precautionary framework emphasizes the importance of taking proactive steps to minimize EMF exposure, even in the absence of conclusive scientific evidence. This approach recognizes the potential risks associated with EMF and promotes a precautionary approach. A key issue with two-wire three-way switching is that the current in the travelers is not balanced, resulting in a net magnetic field around the wiring. This is particularly noticeable when the switch is in certain positions. For in-slab electric heating, a balanced layout would involve running the hot and neutral wires in close proximity to each other, ideally twisted together. This minimizes the loop area and cancels out the magnetic fields. The NEC appendix should also include information on the different types of EMF, namely electric and magnetic fields, and how they interact with the human body. This would provide a more comprehensive understanding of the potential health effects. Considering low-cost EMF reduction strategies and code development can lead to widespread adoption of beneficial practices without significant economic burden. This is a key factor in promoting EMF safety in all electrical installations. The World Health Organization's initiative to address EMF exposure is a significant step toward protecting public health. By incorporating EMF awareness and mitigation strategies into electrical codes, we can create safer and healthier environments for everyone. The issue with two-wire three-way switching isn't just about the return path, but also the fact that the current in the two traveler wires is never balanced, leading to a persistent magnetic field. The ideal in-slab electric heating system design would incorporate a closely spaced grid of heating elements where the current flow alternates direction in adjacent wires. This would result in significant magnetic field cancellation. The NEC appendix should also offer guidance on how to properly ground electrical systems to minimize ground current, which can be a significant source of EMF. Low-cost measures like using shielded cables and properly terminating them can drastically reduce EMF emissions. These strategies should be prioritized in code updates. The WHO's Precautionary Framework encourages a proactive approach to EMF management, emphasizing the importance of reducing exposure even when scientific certainty is lacking. This framework guides decision-making in the face of potential risks. A critical factor in two-wire three-way switching is the loop area created by the traveler wires. Minimizing this loop area through careful wiring practices can significantly reduce EMF. In slab heating systems, consider using a mineral-insulated cable for the heating elements. The close proximity of the conductors in this type of cable helps to minimize EMF. The NEC appendix should also include information on how to properly bond metal conduits and enclosures to minimize EMF emissions. Proper bonding helps to create a low-impedance path for fault currents, reducing the potential for EMF. Low-cost measures like using metal conduit for wiring can provide significant EMF shielding. This should be considered as a standard practice in areas where EMF exposure is a concern. The WHO's initiative to address EMF recognizes the importance of public health and safety. By implementing EMF mitigation strategies in electrical codes, we can create healthier environments for people to live and work in. The key to reducing EMF in two-wire three-way switching is to minimize the loop area created by the traveler wires. This can be achieved by running the wires close together and avoiding unnecessary bends. A well-designed in-slab heating system should use a balanced layout with closely spaced conductors to minimize the magnetic field. The NEC appendix on EMF should include information on how to measure EMF levels using a Gauss meter and how to interpret the results. Low-cost EMF reduction measures can include using twisted pair wiring, which helps to cancel out the magnetic fields. The WHO's Precautionary Framework is a valuable resource for understanding and managing the potential risks of EMF exposure.